variables. So variables. So variables are just symbols or letters used to represent an unknown value. So variables such as, let's say, x, y, or z, or even Greek symbols such as alpha, beta, or even theta, and a lot more. So there are a wide variety to choose from. However, some symbols are usually used to denote some specific variables. Let's say t is usually used to represent time. So this is time. And sometimes s. S is denoted to use for displacement. So this is for displacement or the distance traveled. So take note that we use s. So we use s for the displacement. Since the variable d, so why not d? Since the variable d is already reserved to represent a differential. So this is for differential. We will cover more of this in our future videos. So in this video, we are more concerned with the dependent and independent variable. So the dependent and independent. So independent variable. To understand this, let's have an equation, for example. So let's say we have y is equal to x squared plus 7. From the previous video, we have discussed that in this case, in this example, x is our input. So this is our input and y is our output. So this is our output. So from the previous video, we already have learned what are these two variables are. So we have our input and our output. So however, in this video, we want to know what is the dependent and what is the independent variable. So as you may assume, since the color matches, our dependent variable is our output. So in this case, it is white because y is dependent. So it is dependent to the variable given to the independent variable, which in this case is our x. So the dependent variable depends on the value of the independent variable. So it differs depending on the independent variable. Okay, so take note that selecting the correct dependent and independent variable will be very important, since interchanging the two may result to an equation that does not represent a function. So remember, not all equations are functions. So functions. So remember this, not all equations are functions. We can represent functions as in an equation form, but not all equations represents a function. So not all equations represent a function. So in our next video, we will learn more on how to determine if a specific equation really represents a function or not. So let's have another example, and this will be useful in applications or even in solving problems in physics. So let's say we have, let's now use our symbols. So let's have, if the displacement of, let's say, a ball is, let's say we have dropped a ball from a building. So the displacement of the ball is defined by this equation. Let's say 50 minus 4.9 t squared. Okay, so the distance or the position of the ball is represented by this equation. So with this, we can easily define, or we can easily find what is our input and what is our output. So our input is our independent. So time is our independent variable and s is our dependent. So by graphing this function, so if we could graph this, we have our horizontal and vertical axis. So remember that the independent variable is always located at the horizontal axis. So this is the independent variable, and our variable in this case is t. From the previous video, we have used x, but in this case, our independent variable is now t, and our dependent variable is s. So s will be at the vertical axis. So independent variable goes to the horizontal, and dependent goes to the vertical axis. The trick here is if you see time, time would most probably be the independent variable since time is consistent.